Good evening, everyone. Okay, so let us start. Can all of you hear me? Can you hear me, everyone? Okay. Okay. All right. So this is where we left it yesterday, right? Okay. So now we're going to continue with the next topic, right? Um I got a query regarding the example 3.4, right? That you are not getting the answer given in the book. Is it that? So apparently there is a mistake in the question, or basically the solution given is different, right? Okay. So I hope you did note it, and I hope you didn't get confused, right? If the answer didn't match, right? Okay. So now the next topic that we are going to cover today is well, it's power loss in conductor. All right. Okay, we're going to talk about the power loss in conductor. Okay, so let's start with that. This is actually Joule's heating that you studied in 10th standard, right? But now we are going to take a slightly different viewpoint, right? We're going to take a slightly different viewpoint of the same thing, right? Okay, so let's begin. So let's begin with that, right? Okay, so power loss or ohmic loss in a conductor, right? So whenever some current passes through a conductor, there is always some power loss, right? Okay, there is some waste of energy, right? That is called the power loss or the ohmic loss, right? This is actually same as Joule's heating that you had earlier. All right, this same as Joule's heating, right? It's just a different name, that's it. Okay, so now what we have here is, suppose you consider that this is a conductor, right? Suppose you consider that this is a conductor, right? Okay, right. Let's say this conductor has resistance R. All right, let's say this conductor has a resistance equal to R. All right, okay, and it is that, suppose we connect it with some battery, right? Again, the role of battery, what battery does is that battery provides potential difference, right? Or battery provides voltage, okay, right? So what happens is that if you consider this end A and if you consider this end B, right? Okay, and let's say this is a battery whose voltage is V, then what battery does is that due to the connection of battery, we have a potential difference, right? Due to the connection of battery, we have a potential difference. V is equal to potential at A minus potential at B. I hope that is absolutely clear to all of you, right? Okay. So now, if you would think about one typical electron, right? Okay, if you would think about some typical electron, right? Okay, and let's say that electron is close to the left end, all right, and it's doing random motion. Okay, that electron is doing its usual random motion, and there's also going to be some drift because of the battery connected, so there is a potential difference or there is an electric field, right? Okay, so what I'm asking you is, if you will consider an electron that is over here, all right, okay, right, and let's say that it drifts, okay, and after it drifts, let's say it reaches here at this end, right? What I'm saying is that there is an electron, it's of course doing its random motion, right? Okay, and there's also its drift because we have connected a battery over here, so there's an electric field and current will flow and all that. Okay, so what I'm saying is, as an electron flows from this point to that point, okay, from A to B, right? As an electron flows from A to B, I hope you realize that the electron is actually going from a point of higher potential to a point of lower potential. I hope nobody has any problem with that, because clearly, because we have connected battery like this, so that positive is here, negative is here, so that A is at higher potential and B is at lower potential, right? So now think about it. Whenever any charge moves, right? Whenever any charge moves, actually, I just said it wrong. Just give me a minute. Electron will actually go from B to A, right? And current will flow from A to B. All right. Okay, I just made a mistake in the direction over there. Okay, so what I'm saying is that whenever any charge flows, right, there's always going to be a change in potential energy, and there's always going to be a change in kinetic energy, right? I hope you remember what we have studied in the previous chapter, right? Okay, so now I want all of you to consider that as the electron moves from B to A, as electron moves or drifts from B to A, okay, its potential energy is going to change. So kinetic energy will also, kinetic energy should also change. I repeat, as the electron moves from B to A, its potential energy is definitely changing, because the potential at A and B is not the same. They are different, right? This is clearly different, right? VA and VB, they're different. So delta U is definitely there. There is some change of potential energy, right? And I'm sure you realize that with situations that we have been talking about earlier, along with a change in potential energy, there's generally a change of kinetic energy also, because if energy is conserved, then we can say that delta U plus delta K is equal to 0. But unfortunately, this is not true here, right? Unfortunately, this is not true here. Why? Let's talk about it. Listen to this very carefully. Listen to this very carefully. I'm saying that if you consider some electron over here which is drifting, all right, it has its random motion, it has its drift velocity, right? So whatever is the kinetic energy of the electron, that will be due to random motion, and plus it will be due to drift also, right? I don't think anyone has any problem, right? But because the current here and the current here, I, same everywhere, right? I hope you realize that the current will be same everywhere, right? Okay, current is like water flow. I hope all of you realize that. If you take a pipe, okay, and if you sit and watch over here how much water is flowing through this in 1 second, suppose 2 liter per second, then the same amount must be flowing out through this also, right? There's no doubt that the current has to be same. So what I'm saying is that because the current is same, the drift velocity is same, so drift kinetic energy is same. And similarly, the kinetic energy of random motion is of course going to be on an average same, right? Because on an average everything has VRMS velocity, right, for random motion. Okay, so what I mean to say is that although what we are talking about here is that as it goes from B to A, as the electron goes from B to A, its potential energy definitely changes, right? That is, U changes. U is changing, definitely, because V is changing, but K is not changing. That's a bit odd, right? Okay, right? K does not change, right? No change in K. Why? Again, because the drift speed will be same, and the random motion on an average is going to give the same energy, right? So what's missing, right? So I hope you realize this is definitely not true, because the law of conservation of energy used like this would say if potential energy would increase, then kinetic energy should decrease. But here one is changing, the other is not changing. Have you understood this so far? Is this clear? What I've explained, is that clear? A concept hoto, concept. Okay, why it happens, that's what I'm going to talk about now, right? So definitely something is missing, right? Energy cannot be destroyed. I'm sure all of you realize that energy cannot be destroyed, right? So where did that change vanish, right? Where did it go? Suppose potential energy would have decreased, right? Suppose potential energy decreased, then kinetic energy should increase, but it did not increase, right? Where did it go? The answer is it got lost, right? It got lost. So let me write that now. Okay, see, I'm writing a proper answer here. Okay, all this is okay, no problem, but this is the main thing, right? So due to connection of battery, VA minus VB is the voltage, right? So we should just write that if charge dq flows from one end to another end, there is a decrease in its potential energy, right? Okay, there is a decrease in its potential energy by an amount dq into V. Why? See, this is delta U only. Think about delta U, right? Think about delta U, change in potential energy, that is equal to charge into potential difference. I hope you all remember this relation, Okay, right? So that's what we are writing. Okay, so what I'm basically saying is that if you consider some charge to flow from, let's say, one end to the other end, like let's say we are talking about electrons. Okay, right? So if some charge flows from one end to the other end, there's definitely going to be a decrease in its energy, potential energy, right? Okay, right? So this decrease should ideally appear as kinetic energy, right? This decrease does not appear as increase in kinetic energy, but is rather lost in collisions with ions. I hope you understood this sentence, right? Did you understand this sentence? So what we are saying is that ideally this should happen. Ideally kinetic energy should increase, but it does not increase. Why does it not increase? Because the energy is lost. Okay, because the energy is lost. Where is it lost? It is lost in the collisions, right? Collisions are occurring, so because of those, the energy gets lost. Okay, I hope that is absolutely clear, right? So that is what is going on over here, right? So that's why I can say, thus, when a charge dq flows through this conductor from one end to the other end, there is an energy loss, right? When the charge flows from one end to the other end, there is an energy loss, which is, okay, which is equal to what? Energy loss equal to dq into v, correct? Energy loss equal to dq into v, right? Okay, and this loss appears as, or this loss, yeah, appears, okay, just show it as appears as heat generated in the conductor. Okay, so three simple steps to understand all the idea. First, when charge flows, because there is a potential difference, there will be a decrease in potential energy, right? Okay, but we see that it's not decreasing. We see that kinetic energy is not increasing, right? Does not appear as increase in kinetic energy, right? But where does it go? It is lost in collisions. Now, if it is lost in collisions, then there should be a heat generated, right? Because energy cannot be just destroyed like that, okay? Right? So that energy loss appears as heat generated. So based on that, I can write heat loss H is equal to dQV. Is this okay? Any questions about anything so far, everyone? Any questions about anything so far? હવે થોડુંક મેથ્સ અને બે સ્ટેપમાં ઓલો આન્સર આવી જશે. H equal to I square RT આવી જશે. All right. Okay. So finally, right, you could say that if this heat, oh no, sorry. Yeah, so if this charge took time dt to flow, then H is equal to I dt into V, right? Okay, because why is it so? Because I is equal to charge flowing per unit time. Okay, clear? So now, so based on this, I can say that heat generated in time t is H equal to IVT, right? H equal to IVT, okay? Or I square RT, again using Ohm's law, all right? Okay, I don't think anyone has any problem with that, right? Okay, or also V square by R into T, right? Clear? So these are three simple relations. But see, I would like to warn all of you. This is what you learned in 10th. Very good. This is still valid. But don't forget that there is a condition. These three relations are only true. These three relations are only true if current is constant. Okay? Please don't forget that. Right? These three relations are only true if current is constant. What to do otherwise? Okay, that's special. Right? લગભગ આવું બોર્ડ એક્ઝામમાં નહીં પૂછે. Okay, but otherwise, did you understand this one? અહીંથી આવ્યો અહીંથી આમાંથી. Okay, all the way from here to there. Clear? Right? If current is variable, then you will have to do integration. I don't think you are surprised by that, right? Now you would have I mean, you would almost be expecting that whenever things are changing, then we have to do integration, right? We don't have a choice, right? Okay, so this is how you could do it, right? So please remember, if current is changing, then you must do integration. All right? Okay. Yeah. Now, little bit about power loss. Just one step. Power loss is obviously, I'm sure you understand that roughly speaking, power loss should be defined as rate of generation of heat per unit time, right? Rate of generation of heat per unit time, that's going to be nothing but VI, correct? Or I square R or V square by R. આમાં કઈ સમજાવતો નથી હો હવે, આવું તો બધું આવડે જ છે તમને, right? Okay, and this power loss is also called ohmic loss, and this kind of heating is called Joule's heating, right? Or Joule heating. Clear? એ બધા એના નામ છે, ભૂલી ન જતા નામ, right? So let's go to the next thing, right? Now this is based on something. I'm going to change it. Is that okay? Everyone has written whatever they want to write. Shall I change it? Okay. આજે ઊંઘ આવે છે કે શું બધાને? Fine. So now let me just ask you a question. Have you ever been, to some different places and where there are such very tall towers with wires on them, right? Have you seen those wires which supply electricity, right? They are on very tall towers, right? And generally over there, a board or something like that is written high voltage or high tension. Something like this is mentioned over there. Have you seen it? Right? So sometimes like this is about 22,000 volt, right? Or, even more than that sometimes, right? Okay, but in your house, you are using only 220 volt, right? Fine. Okay. So in your house, you're using 220 volt, right? So why is electrical power transmitted, right? That is where there are, these are called transmission lines, correct? These are called transmission lines, right? So why is electrical power transmitted at a high voltage, right? Okay, shouldn't they just give 220 volt directly from all the way from the power station, right? No, Vivek, it won't be true ever. Delta K plus delta U will not be equal to 0, right? Because if current is flowing through a conductor, then there will be resistance. Okay, let's just go back a moment. Vivek is asking a question. I want to clarify this to everybody. Here we have said that whatever is the decrease in potential energy, right? Here we have said that there is a decrease in potential energy, right? But that decrease does not cause increase in kinetic energy, right? So of course delta K plus delta U will not be 0 in such a case, right? But the truth is that this does not happen anytime there is a resistance. See, that's what we are talking about here, right? Suppose resistance would be 0. Suppose resistance would be 0, then this would also be 0. Okay, if resistance would be 0, then this would also be 0, right? But I hope all of you realize that this is actually an ideal case, right? This is actually ideal case, right? This never happens. Okay, so suppose there is vacuum, right? Suppose there is vacuum and here is one electron, and somehow you create electric field. Let's say electric field is in this direction, external uniform electric field, right? So then this electron will definitely move from here to there, right? Okay, but as it comes towards right side, its speed will increase, velocity or speed will increase, right? I hope that makes sense. And that is because as it goes towards right side, if I take 1 point here, 1 point here, right, clearly VA is higher potential than VB, right? That's why electron's energy is more at B than at A, because charge is negative, right? I hope you got that. So in vacuum, of course, delta K plus delta U equal to 0 will be true, right? In vacuum, delta K plus delta U equal to 0 is true, right? Because of course vacuum has no resistance. But whenever it's flowing through a metal, and every metal has some resistance, right? It can't be 0. Understood, Vivek and everyone else, right? That when we are talking about current flowing through a wire or a conductor or even an insulator for that matter, any material, right? This is never going to happen, right? Okay, fine. Let's go to what I was saying. So I was asking you, why is electrical power transmitted at high voltage, right? Why at this? Because ultimately it has to be converted to low voltage, right? Because current flows from high voltage to low voltage. No, that's wrong. See, I'm not, everyone, you should understand, I'm not saying that this point is at 22000 volt and your house is at, I'm not saying that your house is at 220 volt. No, what we are saying is, suppose these are the two wires in which current will be flowing. એકમાં કરંટ આવશે અને બીજામાં જશે એવું હોય, બરાબર ને? So the potential difference between these two near a power station, suppose this is power station, here it is going to be 22,000 volt, barabar? But then when the same line comes to your house, okay, it goes inside your house, here the potential difference is 220 volt, right? So you can't say that it is going from higher potential to lower. Wrong. Yes, Avinash, your answer is right, but how does that help? That's what we are going to talk about. Okay, I thought you would say something more, so I was waiting for you. No, there will see everyone, people. I want all of you to understand this very carefully. I want all of you to understand this very carefully. If you have got wires, right? If you have got wires, voltage cannot be lost because voltage is not like power, everyone. Also, nobody can consume voltage. Let me tell you, nobody can consume voltage. This is impossible to do, right? Power can be consumed, okay? Power can be consumed, okay? Voltage cannot be consumed. Okay, fine. So let's talk about this now. Okay, let me give you the proper answer. Okay, see, this is as follows. Have you seen? Have you seen that almost every device that you are using will have input return to be about 220 volt AC? આવું કંઈક લખ્યું હોય એમાં તમે જોયું છે, વાંચો છો કે નહીં? Yes, Avinash, it is true. What you said is right. Okay, that means almost every device must use a same voltage, all right? Every device must use same voltage, right? Okay, on everything. Okay, on everything. TV માં 220 વોલ્ટ લખ્યું હોય, ફ્રીજ માં લખ્યું હોય, લેપટોપ નું ચાર્જર હશે તો એમાં એવું જ લખ્યું હશે, ફોન ના ચાર્જર માં એવું જ લખ્યું હોય, બરાબર ને? બધે 220 વોલ્ટ લખેલું હોય, right? So that means all devices are using same voltage, and if you take a TV and give it 50 volt, then it will not work. Okay, right? I hope you understand what I'm saying, right? So you have to maintain this cannot be changed, right? This has to be maintained, this cannot be changed, right? So what is done is, listen to this carefully. If your device needs power, suppose your device needs power, okay, let's say it needs 100 watt. Okay, let's say your device needs 100 watt power, okay? Then there are two ways to do it, suppose, right? I'm not going to use 220 volt as an example, I'll use 200 volt as an example, so that makes it easy for me to write the number, so you'll understand it easily, right? So this 100 watt can be given in two ways. Remember, power is V into I. Remember, power is V into I, right? So you could do it in two ways, 200 volt and half ampere. I hope that makes sense. 200 volt and half ampere. Another option is this. Agreed? Or even worse? Possible, right? All the three give same 100 watt. Then your device will work, right? In all the three situations, device will work properly. Device works properly, right? There will not be a lot of problem, right? It's not like it's going to be damaged or it won't work. But then why do we choose this one, right? What I mean to say is, why do we give high voltage and low current over low voltage and high current, right? Everything gives same power. I hope that makes sense, right? But this is preferred, this is not preferred, right? Okay, this is not preferred. The reason is as follows. If you want every device to be consuming 200 volt AC, let's say, right? Let's say every device is consuming, or sorry, not consuming, is using 200 volt, right? Every device needs 200 volt maintained. So what you can do is, in the transmission lines or in the power lines, okay, like I said, you have choices. Like I said, you have choices, right? You have three choices, but we will choose this. What's the reason? Let's talk about that. It is that whenever this is the transmission line or power line, it has its own resistance R, right? So the power loss in the transmission line, okay, in the transmission line, whatever is the power loss is of course going to be I square R, right? I square R, right? Okay, so now let's assume for simplicity that only one device is working in your house. Okay, let's say only one device is working, everything else is off. Okay, right? So what happens in this situation is whatever current your device consumes, that we have to put here because the power line will have to give that much current, right? Okay, so if your device consumes high current, if your device consumes or uses high current, okay, let me just write that. If your device uses high current, then the power loss in the transmission will be more. See, you need to separate these two. Power of device is V square by R because generally devices work on a constant voltage. I repeat, devices work on a constant voltage, but power loss in transmission is I square R. તમે એમ કહેશો સર અહીંયા V square by R નો લખાય? લખાય જ નહીં. This is not wrong, but this will not work properly mathematically because V is not same. પાવર સ્ટેશન ને એનાથી મતલબ નથી કે તમે કેટલા વોલ્ટેજ યુઝ કરો છો, એ તો ફિક્સ જ છે. I repeat, the power loss of transmission lines should be written like this, okay? Because if you take one device, right, and it is consuming some energy, right, okay, to give that energy current must pass. Now if you will use one device that uses high current, then it needs more value of I. પોતે તો ભલે આટલો જ પાવર યુઝ કરે એ બરાબર, but if that value of current is high, then the value of I will be high and the power loss in transmission will be high, right? So I hope you realize that for every device you have two choices, like I mentioned earlier, high V, low I, or opposite, low V and high I, right? So like I said, we prefer that I has to remain low as far as possible, right? Okay, so that is what goes in over here, right? That if you want to minimize the power loss, in transmission, check ક્યાંય power station હોય ને, right? If you think about Surendranagar, then the closest power station is in Sabarmati, right? I hope you understand what I'm saying. તો સાબરમતી થી છેક વાયર નાખેલો છે તમારા ઘર સુધી. Don't you think it will have a very high resistance because the length is so much? I hope you understand what I'm saying, right? So the only way to minimize the power loss is to keep the value of I low. પણ પાવર તો આપવો જ પડે. તો આ સિચ્યુએશન થાય. અહીંયા જો, if you want to keep I low, you have to give it at higher voltage, બરાબર? તો હવે આપણે શું કરીએ ખબર છે? What we do is, from the power station, we transmit it with a potential difference of suppose 22,000 volt. So this is such a high voltage that if you want to give any power, P, then P is V into I. So the current that must flow is actually very small. I hope you realize because the voltage is very high, the current that must flow is very low. Agreed? Right? So if current flowing is very low, then the power loss in transmission, which is I square R, is also quite low. Right? Okay. So that is exactly the reason why we keep we keep the voltage high over here, right? But of course you can't use it. Suppose you try to use 22,000 volt in your house. ભૂલથી ક્યાંક અડી જાય તો ચોંટી જાઓ, મરી જાઓ, right? So this is not safe. Okay, so what we have to do is we have to put transformers. જોયા છે ને ટ્રાન્સફોર્મર્સ બધી જગ્યાએ રોડ ઉપર સાઈડમાં થાંભલામાં હોય છે, right? So these transformers will convert that 22,000 to 220 in series of steps. Okay, એક વારમાં ન થાય, અલગ અલગ જગ્યાએ અલગ અલગ હોય. Finally it becomes 220 volt that you can use easily and it is safer, right, compared to this. All right, so that is the whole idea behind it. Power is also equal to V square by R. Very good, right? Then I was expecting at least one person to ask this question, right? Power is equal to V square by R. નહીં તો તમને એવું થાય કે સર આપણે એ ફોર્મ્યુલા આમાં યુઝ કરીએ તો શું થાય? બરાબર ને, એવું થાય છે ને, એ ફોર્મ્યુલા આપણે આમાં યુઝ કરીએ તો શું થાય, right? But once again, let me clarify what I said. This power loss V square by R is not going to be still very high for one simple reason. તમને એમ થશે સર આપણે V ની વેલ્યુ ઓછી રાખીએ તો, right? If you keep V low, wouldn't power loss in transmission be low? Unfortunately not, right? Why so? Why so? Let's talk about that. It is that this is, although it looks to be the correct formula of power loss, this is not the correct formula of power loss. Let me tell you why. This works for power of a device, everyone. This works for power of a device when V is same, right? This works for power of a device when V is same, right? Okay, the truth is that if you consider a long wire like this, okay, બધે resistance હોય તો આ point થી આ point સુધી potential difference વધારે હશે, પછી આ point થી આ point સુધી potential difference ઓછો હશે, પછી ધીરે ધીરે ઓછો થતો જ જાય, આ બે point વચ્ચે હજી ઓછો થાય, આ બે point વચ્ચે હજી ઓછો થાય. That does not mean it will become 220 on its own. કોઈ એવા વહેમમાં ન રહેવું. I repeat, I am not saying that if you start with 22,000 you get 220 on your own ને વચ્ચે કઈ જરૂર ન પડે. That's nonsense, right? So if you suppose start with 220, તમને એમ થાય કે ચલો આપણે low voltage જ રાખીએ. Suppose you would start with 220, okay? So what will happen is around the power plant nearby, okay, nearby the power plant you would get enough voltage, no problem, right? But if you even talk about Surendranagar, we'll have a problem, right? The problem is that if you start with 220, the bulb in your house, right? Let's say you want to use this bulb, right? That bulb in front of your house will not even get 50 volt, right? Will not even get 50 volt, right? So that's one problem. Let's talk about another problem. As more and more people, કઈ ખાલી તમારા ઘરની પ્રાઇવેટ લાઈન તો છે નહીં ને પાવર પ્લાન્ટ થી, છે કે છે કોઈની પાસે, કોઈના ઘરે છે? Is there anyone who has a private line from power plant to your house? કોઈ છે એવા? હે, નથી ને? કે છે કોઈ? કેજો હોય તો પ્રાઇવેટ લાઈન. So yes, Harsh, you have it. Okay, very good. All right. તો બિલમાં કેટલા ઝીરો આવે પાછળ? Okay, so why am I asking you that? The reason is when a whole town when a whole town is connected, when a whole town is connected with the same line, right? So one bulb does not consume that much power, right? Lots of bulbs will consume a lot of power together, right? I hope that makes sense. Okay. So at that time, it is evident. Harsh, my question was, do you have a private line? My question was not what your father's occupation is. All right. Your father's occupation has no effect on this, right? Okay, whatever your father's occupation may be, you cannot get a private line from from a power station or power plant to your house. Nobody can afford it. Okay, anyway, let's not get diverted. So what I was saying is that even if you consider that there are lots of people and using their devices, that would be consuming a lot of power. In such a case, in such a case, if you are trying to only give 220 volt, there is no way that each and every device can have that much power by such a low voltage, right? This voltage is simply too low for it to work, right? So what will happen is from the power station, there needs to be a huge current, right? સીધી જ વાત છે. If V is low, I has to be high if you want to give power, right? I hope all of that is clear when we look at these numbers. બરાબર ને? આ તો ખાલી તમે 100 વોટ વાપરો છો, બાજુવાળા 100 વોટ વાપરતા હશે, સામેવાળા 100 વોટ વાપરતા હશે. So the current that will be emitted or has to be given out by the power station is tremendously high. તો બહુ વધુ કરંટ હોય તો શું થાય? કઈ પ્રોબ્લેમ થાય? Of course, yes. Whenever the current is very high, listen to this carefully. There's something which we have not talked about yet, પણ તોય તમને basic idea આપી દઉં. Have you heard of magnetic field? Have you heard of magnetic field? Yes or no? Do you know what is a magnetic field? Right? And I'm sure you might have studied it in 10th that whenever a current flows, there is always a magnetic field. Right? Current produces magnetic field. Right? એવું આવતું હતું ને 10th માં. Current produces magnetic field. ઓલો રાઈટ હેન્ડ થંબ રૂલ એવો કંઈક આવતો હતો કે વાયર આમ હોય તો એની આજુબાજુ આમ સર્કલમાં મેગ્નેટિક ફિલ્ડ હોય, આવું કંઈક આવતું હતું. હા, એ આપણે આવવાનું છે ને પછીના ચેપ્ટરમાં. Okay, so if current is very high, the magnetic field created is actually quite high. પછી શું થાય ખબર છે? This magnetic field starts to create problems in other things. એટલે એવું કે આ તમારી દિવાલની અંદર વાયર છે, right? Suppose this is a wire inside your wall, okay? એની અંદરથી આવે છે, but here the current is very high. Let's say 2000 ampere. બરાબર ને? Let's say 2000 ampere, right? તો પછી તમે ઈ દિવાલની બાજુમાં ફોન લઈને જાઓ ને તો ફોન બંધ થઈ જાય. It will get damaged. Right? Why? Because the magnetic field of this wire would start leaking out. Generally એવું હોય, ઓલું નથી તમે જોયા છે એવા વાયર્સ હોય કે જે એક આમ થિક વાયર હોય ને એની અંદર પાછો એક બીજો નાનો હોય, આવું જોયું છે? ડબલ વાયર લાઈક. Have you seen such a thing? Okay, never mind. So such things are used to actually prevent magnetic field, right? Such, yes, and a shielding, right? That's right. Such things are used to prevent magnetic field from going out, okay, or from outside magnetic field from coming in. But anyways, so what happens is that such if you allow such high current, there will be this problem also, right? પછી તો એવું થાય કે ઓલા બર્ડ બચારા શાંતિથી ઉડતા હોય ને વાયરની બાજુમાંથી, એ વગર વાંકે ચોંટી જાય, right? Okay, so anyways, so that's it. That's I think enough for this topic. It is that overall, if you want to keep the loss in transmission, see, I'm being very clear. I'm talking about loss in transmission. એટલે જ્યારે current flow થાય from power station to your house, right? Yeah, Avinash, though that is not going to happen because of chemistry, right? So the loss in transmission, if you want to keep it low, then it is necessary that current is low and voltage is high. Okay, right? It is necessary that current is low and voltage is high, right? Only then you could do that. Okay, so that's what we have, right? Okay, now let's go to a very easy topic, right? 7 મિનિટ છે, 7 મિનિટમાં પૂરું થશે, બરાબર? કારણ કે 10th માં આવ્યું હતું. ઓકે, resistance in series. How many of you say I should skip? Vote yes or no. Skip yes or no. Skip yes or no. Okay, fine. Many of you are saying no, so I'll just do it very fast. Okay. ઘણા લોકો તો વયા ગયા, બોલો. અરે આવો ક્વેશ્ચન પૂછ્યો, એના આન્સર એ તમને આપતા ભાગી જાઓ છો. Yes, I am explaining. Don't worry, I am explaining. So suppose there are 3 resistors in series. Okay, R1, R2, R3, right? And let's say we connect them with a battery, right? And let's say that a current I is flowing, right? Now clearly I hope all of you realize that current has nowhere else to go. રસ્તો જ એક છે ને, તો આમ જવું જ પડશે ને. Is that okay? So same current will flow કારણ કે એક જ પાઇપ છે, if you understand it in that language, right? So there is same current everywhere, right? So just write it in series, current flowing in each resistor is same, that is I. Okay, is same, that is I. બરાબર? અને potential difference અલગ હોય ને. Suppose I call this point A, this point B, this is C, and this is D, right? Okay, and see, I want all of you to understand. I want all of you to understand that this blue wire is ideal wire. Okay, I want all of you to understand that this blue wire is ideal wire. ખાલી resistance ને જ resistance છે. Okay, ideal wire means no resistance. All right, so then V is equal to, આવું કેપેસિટરમાં કર્યું હતું, કેપેસિટરમાં કર્યું હતું ને, કે સિરીઝમાં વોલ્ટેજ એડ થાય, યાદ છે ને બધાને? ક્લિયર? વચ્ચેનો સ્ટેપ કોઈને જાણવો હોય તો આવું લખી શકાય. This, right? Okay, I will have V1 plus V2 plus V3, and now use Ohm's law. Okay, by Ohm's law, right? We will get V is equal to I common R1 plus R2 plus R3. અને હવે equivalent circuit. હવે equivalent circuit. So R equivalent, battery. Okay, right? So you could just write in equivalent circuit, V is equal to I R equivalent. Okay, so compare 1 with 2. Have we given an answer? Right? Comparing or putting value. J lakhu, putting value lakho to chale. Right? Put V is equal to this over here. So I Req equal to I R1 plus R2 plus R3. Okay, so I is cancelled. Right? So I is cancelled and we get Req equal to R1 plus R2 plus R3. Right? આવી ગઈ formula. This is for series. Right? I'm going to change the page. બરાબર ને? હવે વાંધો નથી ને કોઈને? Those who said no, I'm just a bit concerned about you. Is this absolutely clear? Those who wanted me to do it, is this absolutely clear? આમ તો યાદ આવી ગયું હશે, 10th માં તો આવડી જ ગયું હશે, I'm sure. Okay. Now parallel. Okay, parallel. Resistance in parallel. તો પેરેલલ માં સેમ શું હોય? વોલ્ટેજ સેમ હોય ને, યાદ છે ને? પહેલા સર્કિટ ડ્રો કરી નાખો. Again here, please remember, જો અહીંથી ડ્રો કરાય, અહીંથી એ કરાય, ગમે તેમ કરો, બે ચાલે, બધું સેમ જ છે, એમાં બહુ ટેન્શન નહીં લેવાનું. Okay, so this is what we have, right? Okay, so now this is battery with voltage V, this is R1, this is R2, and this is R3. Okay, right? So if you take points A, B, C, D, E, F. Okay, so of course we have this and we have this, right? Don't forget that this is ideal wire. Okay, હવે છે ને અહીંયા ધ્યાન રાખવાનું, જો બધા, this is current I, right? Then that current will be split એટલે divided. જો એવું વિચારો કે અહીંથી પાણી આવે, બરાબર, ને પછી એક અહીંયા જગ્યા છે, અહીંયા પાઇપ છે અને અહીંયા પાઇપ છે, તો ત્રણેય સાઈડ જશે ને. I hope you understand what I'm saying. If suppose 100 liter per second is coming from here, then possible that 50 liter per second will go over there, 30 liter per second will go over there, and 20 liter per second will go over there, right? Okay, so here current is distributed. So suppose first resistor ma I1, second ma I2, and third pipe ke third resistor ma I3. Arey sorry, ઊંધા લગાઈ ગયા, I'm so sorry. Okay, I1, I2, I3, clear? So we should write it as follows. Everyone, we should write it as follows. As as resistors are in parallel, their PD or voltage is equal. Okay, is equal, and that is how much? V, right? V. All right. Okay, now but you could write, but total current through battery, that is I, is distributed. This is the important word, distributed, separated, alag thai, right? Total current through battery, that is I, is distributed, right, into I1, I2 and I3 through the resistors respectively. Okay, so through each resistor the current is distributed respectively right? Of course we have I is equal to I1 plus I2 plus I3. અચ્છા, તમને એવું લાગે કે એમને આવું લખી નખાય તો એનું રીઝન લખવું હોય તો લખી નાખો બાય લો ઓફ કન્ઝર્વેશન ઓફ ચાર્જ. આ એનું સાચું રીઝન છે, બાય લો ઓફ કન્ઝર્વેશન ઓફ ચાર્જ. કેમ કેમ એવું? અરે સીધી જ વાત છે. અહીંથી જેટલું આવે અહીંયા ક્યુ, સપોઝ અહીંયા ક્યુ ચાર્જ ફ્લો થાય તો એ ક્યુ પછી ડિસ્ટ્રીબ્યુટ થશે તો કંઈ ડિસ્ટ્રોય તો ન થઈ જાય ને. ઇફ ચાર્જ ક્યુ ઇઝ ફ્લોઈંગ then that q should be equal to flowing in first, flowing in second and flowing in third. એનું ટોટલ થાય, રાઈટ? and if you take its differentiation તો બધે I hope that makes sense, right? So this has actually come from law of conservation of charge. પણ આટલું બધું ડિટેલમાં લખવાની જરૂર નહીં હોય એક્ઝામમાં. ઓકે, આ તો ખાલી તમને એકદમ ડીપમાં સમજાવું છું કે કઈ રીતે બધું આવે ખરેખર. ઓકે, રાઈટ? સો I is equal to I1 plus I2 plus I3. ઓકે, આટલું લખાઈ ગયું. હવે શું લખવાનું ખબર છે? ફોર ઇક્વિવેલન્ટ સર્કિટ. હવે આ ત્રણના બદલે એક જ કરવાના, ફોર ઇક્વિવેલન્ટ સર્કિટ. ઓલરાઈટ, લાઈક ધીસ. ઓકે, તો એમાં કરંટ તો I જ આવે. ફોર ઇક્વિવેલન્ટ સર્કિટ I is equal to V by R equivalent. બરાબર ને? This is Ohm's law, right? This is nothing but Ohm's law. Okay, so use this equation here. અહીંયા વેલ્યુ મૂકી દો. હવે આ ઇક્વેશન અહીંયા વેલ્યુ મૂકી દો, બરાબર ને? So V by R equivalent. Okay, this we are doing by equation 1 and by equation 2 together, right? Is equal to I1 ની જગ્યાએ V by R1, again Ohm's law. પછી I2 ની જગ્યાએ V by R2 અને I3 ની જગ્યાએ V by R3. Clear? Ohm's law everywhere. બસ તો આવી ગયું, થઈ ગયું પૂરું. So finally we get 1 by R equivalent is 1 by R1 plus 1 by R2 plus 1 by R3. So ઠીક છે. હવે આમાં કઈ ક્વેશ્ચન હોય ને કોઈને તો પછી પર્સનલી પૂછી લેજો, બરાબર? મેસેજ કરી દેજો કઈ ડાઉટ પડે ને તો આમાં. ઓકે, આવો જ આન્સર લખવાનો. મેં તમને વ્યવસ્થિત આન્સર લખી દીધો. આનાથી વધુ લખો તો વાંધો નહીં, ઓછું લખો તો માર્ક કટ થશે. ઓકે, ગુડ બાય.